Now, if we take a look at this timeline we just created, we have some vectors we can put in here, and we can transfer these vectors to our light, spotlight's rotation, to move around the lights. But because this is just a set of values you put in, they would be the same every single time. So every single time timeline would finish, we would play it from the start or where it stopped last time, and it will begin again. This is not what I want for this level. I want lights to move around a bit in a certain directions randomly and go back. So we are going to change the way we use our timeline. We'll open our timeline and we will remove this track we just created for vectors and add a float track. And this float track will be between, let's say for now, let's keep it as it is. We're going to call it alpha. We're going to compile it, go back to event graph, and now we have an float value that goes nowhere at the moment. We are going to do it from, let's put it into, let's make it lights rotate for 8 seconds, and in 8 seconds the value will go from, you need to shift click this, the value will go from 0 to 8. 8 seconds. 8-second mark will go to 8. And let's make sure we have it correctly set up. Yes, we have it correctly set up. So we shift clicked it at the key point at 0 time, value 0, to at 8 seconds, value 1. So now this alpha node here is letting us put the value between 0 and 1, and the value will go from 0 to 1 in 8 seconds. For now, let's remove this lines to keep it organized. And we are going to add a lerp vector node. So lerp vector, and we are going to put in our alpha here. Now, to explain what lerp does, lerp function essentially goes from value A to value B gradually, depending on the alpha value. And alpha is usually a value between 0 and 1. And at 0, it is A. At 1, it is B. And this is useful when used with timeline to gradually change the location or rotation or anything really you want to do over time without using event tick. As event tick is, first of all, will not be as smooth as using lerp, and secondly, it's got more performance heavy. So we're going to, for now, test it. We're going to have a value. We will play from start, and we will print string this value. Oh no, we cannot print string. We have too many lights in the scene. So instead, what we are going to do, we are going to move the lights. Now we need to get rotation, but by mistake made the lerp vector. Let's fix this. Lerp rotator instead, as we're going to work with rotation. And we're going to get the rotation of the spotlight. My apologies. Set rotation. Set relative rotation, I believe, is the correct one. As this, the difference between a relative rotation and a world rotation is the rotation relative to its parent would be the rotation of spotlight relative to static mesh. But world rotation would be it is rotation in the world itself. It may be a bit complicated to understand right away, but it is just how it is. You will need to test it out, the differences, as you use Unreal. So we will put this here. So what this will do, we will get a value between 0 and B, and the alpha will do it for us. Slowly rotate. Now, for now, let's put in fixed values. The spotlight value currently is 90y. And rest of them is 0, 0. Let's say we want this to go from 90 to 30. We'll compile it, save it, go back to the level and press play. Nothing is happening. Now, the interesting question is nothing happening because we are not changing the value, or... Interesting. Let's stop. Yes, the issue is the spotlights are currently not movable. So let's go back, click and movable. Now this is more computationally heavy, but for what we are trying to do. Now we have spotlights that move around. As they disappeared because they don't have enough radius, we can increase that radius quite easily. So let's say go to viewport, and currently we have 2000. Let's make it 8000 for now. Press compile, go back. Let's see how it works now. And let's see how lights are set up currently. So we are getting this weird light. Again, it is mostly because of the way it's rotated. Now, let's take a look at our lights and see why this weird artifacts start happening. We don't get proper shadow. So when we rotate this, the light itself, it's fine, but we are actually rotating the blueprint spotlight only. We don't actually rotate the lamp. So when we do this, we get a cutoff, and the reason for that cutoff is because the light is colliding with the mesh, and it's giving us this weird cutoff. To prevent this, we can modify light channels, etc., to not collide with the light of the own mesh, ignore its own light channels, and perhaps we can even create a new mesh that doesn't give us this problem. But the easiest way to fix this is to go to spotlight, move it a bit outside of the mesh, save and press play. And now we will have this kind of range. Now it's fully covering the whole area, which is exactly what I wanted. But we don't want this to happen every single time exactly the same way. What we are going to do now, first of all, I'm going to organize this a bit. I do not like how cluttered it is. And we are going to have this delay node, and we are going to move this all down. Spotlight here. Now, what value we get from that we put in forcefully is original location or rotation of the light, which is 90, and we reduce it to 30 to move it around the scene. But if we wanted to give the wider range, we need to also change other values. So if we put it like this and increase rotation on the z-axis, we can also give it left and right movement. So let's look. Now, the rotation we would like to give it is between 90 and -90. So we have a range of rotation. So what we can do, we can give it a Z minus rotation, for example, and P 90 rotation. Again, this is not final. I'm just doing it for demonstration. And if we press play, we now have rotating lights.